Alright, we're going to be looking at bond order and magnetic property. Very important topic under MOT. Alright, now very simple. Literally, bond order simply means the number of bonds between a pair of an atom. Remember, diatomic molecule that we'll be looking at in MOT is actually separated by bonds. Alright, so those bonds that are separating those two atoms is what we refer to as bond order. Alright, so mathematically it can be defined as number of bonding electron minus number of antibonding electron all over 2. Alright, so we're going to take example of, we're going to calculate bond order of these few molecules now. Now the first one, remember, before you to be able to calculate for bond order, you must be able to know how to write the molecular orbital electronic configuration, the one we just did previously. Now, the first thing you're going to do for the A, that's H2, calculate the total number of electrons present here. And I told you for you to calculate the total number of electrons present is for you to add up the sum of the atomic number minus the charge. Alright? So, hydrogen is atomic number of 1. How many hydrogen do we have? 1 plus 1 minus 0. That gives us 2 electrons. So, this molecule contains 2 electrons alone. When you start writing your molecular orbital, you always start from the lowest energy. And remember, the order follows the bonding 1s and the antibonding 1s, bonding 2s, antibonding 2s, and then the p. So since we have 2 electrons, and also remember, the number of electrons you're going to have in a molecule will determine how many molecular orbitals you're going to make use of. So in this case now, since we have 2 electrons, I can just start bonding 1s, 2, electron has finished. Right, but I'll just add up its antibonding. I'll just add it up. It's not really that compulsory, but in this case now, you just add it up. Now, the bonding electron is actually the electron on this bonding molecular orbital. If you can remember at the beginning stage of this, I explained that this is signed for sigma bond. And we only use it for the s orbital because s orbital only forms sigma. The one without asterisk, in this case now, is the bonding orbital. The one with the asterisk is the anti-bonding orbital. So if you look at this guy, this one now, we have 2 electrons on this s that is attached to this bonding. So from our bond order, let's just abbreviate it with B.O equals to, this is bonding 1s, 2. So the number of electrons on this bonding orbital is 2 minus, remember this formula says number of bonding electrons minus number of antibonding electrons all over 2. So our bonding electron is 2, antibonding electron, there is nothing here, is 0, all over 2. So this gives us 1. So therefore, the bond order of oxygen will now be equals to 1. That is that for this. Now, for B, He2, the same thing, not in the total number of electrons present. They use our formula, summation of the atomic number. This is 2 plus 2 minus 0 because there is no charge here. So the total number of electrons here becomes equals to 4. Now, the number of electrons you have in a molecule will determine how many molecular orbital the compound or the molecule is going to have. Whenever you're writing, always start from the one with the lowest energy and then proceed. So the order is always bonding 1s, antibonding 1s. 4 electron, 2 enters there, 2 enters there, the electron finishes. I stop here. In this case now, my bond order, abbreviated with BO, is bonding electron. The bonding electron is simply the electron on the bonding molecular orbital. So there is 2 electrons here. Remember this one that have asterisk is the anti-bonding. The one without asterisk is bonding. So there is 2 on the bonding, there is 2 on the anti-bonding. So 2 minus 2 all over 2. This is 0 over 2, which is equal to 0. In this case now, this means this molecule cannot exist like this because there is no bond holding both of them together. That's what it means. If your bond order is equal to 0, that means that molecule cannot exist. In other words, no bond is holding them together. Remember I told us that bond order is actually the number of bonds, the number of bonds between pair of atoms. Alright, so it simply means that there will be no bond joining them together. That's what it means. So this compound, this molecule cannot exist. This one can exist and is a very stable compound. So you have to do these two. In our next class, we'll continue from here. Thank you very much for your time. I remain your host, Delzy, and I would like to encourage us to use this opportunity to cover up on courses that we've been finding it so difficult. If you have any issue, if you have any problem, I'll put up my phone number on the board. You can always reach out to me. I'll be glad to help out in any way or in any capacity. So this is 0703-810-1576. All right. Thank you.